Alrighty, so welcome back. We're going to continue from where we left off. So all we're doing right now is that we are just going to be graphing. Alright, so let's just get right into it. So given the equation, description, or function notation, graph the function. Then fill in the information. Right? So say, great. Well, first off, what is this? Is it an equation, a description, or a function notation? It is a equation. So remember, if you actually see an operation like a symbol, that would tell you you have a equation. Alright, so square root is a literal operation, right? Symbol. So all we do is we take that equation, we just copy it down below. Alright. Now the function rule, remember the function rule is literally going to be the exact same thing. The only difference is that we write it in terms of f of x. Alright, so we have f of, and then whatever is on the inside of your function, so x minus 1. Right, and then your two operations on the outside are still there on the outside. Alright, so now let's figure out what we're actually doing to this graph. Let's write the description. So first, I'm going to start with, just going left to right. So we see this negative 3. Now remember, the negative alone is its own transformation. Alright, so first let's write the 3, right? It's outside of the square root, so it is vertical. I'm just going to do v for vertical. Okay, it is vertical. That's a great. What operation is this? Multiplication or addition, subtraction? Well, it's multiplying. So it would be a vertical stretch as 3 is larger than 1. So a vertical stretch by 3. Now you also have that reflection. Now remember, if it's vertical, right, a number on the outside, and negative, it is a x-axis reflection. Okay, so then just keep going left to right. So I'd say excellent. We have this x minus 1 right there on the inside of our function, right? Inside tells us right then and there it's horizontal. And then we look at the operation, right? We have subtract 1. Subtract is a shift. So we're horizontal shift. And I'd say great. Remember, with shifts in horizontal directions, you do the opposite of what you see. So what's the opposite of a negative 1? It's a positive 1. And positive 1 is on the right side of the graph, right? It's in that direction. So it's a horizontal shift to the right by 1. And then we have one last transformation, which is a plus 2, right? It's on the outside, so that would be a vertical shift. And here we do exactly what we see. Positive is up, so we are going up by 2. Okay? Alrighty, so that is all of our transformations. So now let's actually get our table going. So let's say, great, square root. Remember square root, the parent function is 0, 1, 4 and 0, 1, 2 for those points. And then we just put it in. So I say, alright, remember, you're doing any kind of multiplication first. So your stretch and reflection, you jot those down first, right? Vertical stretch by 3, meaning you're multiplying by 3. Now, we can also do reflections at literally the same time, right? I wouldn't bother multiplying by a negative 1 later. Save yourself some effort. So multiply by a negative 3, and that takes care of both stretch and reflection. Okay? And then once you do multiplication, then you can do the shift, right? Vertically, we're shifting those y's up by 2, so we add 2 on that side. If we're going right by 1 on the x's, that means we are adding 1 to the x's. Okay? So then we just fill in the information. We'll just go left to right. So 0 plus 1 is 1, 1 plus 1 is 2, and 4 plus 1 is 5. Alright, outer column. So I'm just going to highlight that now. Right? 0 times negative 3, 0, negative 3, negative 6, then add 2. Alright, and again, still take that outer column. So then your horizontal is the points, right? So we have 1, comma 2. And then we have 2, comma negative 1. And then we have a 5, comma negative 4. Now remember, your square root is that half seagull, right? So we start at the 1, 2 point, and it looks like it's curving down. And that's it. That would be your answer with all the filled in information. So let's do it again, a little faster this time. So here we have given the graph of f of x equals the absolute value of x, graph g of x equals negative 1/2 f of negative 1/3 x minus 4. Alright? So that is the function rule. So I'm just going to copy that down. Okay, now your function rule is literally your equation, right? Except the only difference is now we just use the actual absolute value in here. So we have negative 1/2 with the absolute value of negative 1/3 x minus 4. That'd be your equation. And then your description is when we are just describing what's happening. So first we have a vertical compression or shrink. I'm going to write shrink, a little shorter. A vertical shrink by 1/2. Alright, and that is the 1/2 right there. Then I say, great, we also have a negative on the outside, so that is an x-axis reflection. Alright, and then we look on the inside, we see that 1/3 chilling there. The reciprocal of 1/3 is 3/1, so it is a horizontal stretch by 3. You also see a negative there, which means it is a y-axis reflection as well. And last but not least, then we have that minus 4 on the outside, so that would make a vertical shift down by 4. Absolute value has the points negative 1, 0, 1, 1, 0, 1. So from there we just say, great. First off, we're going to be multiplying the y's by a negative 1/2. Right? We're also multiplying the x's by the reciprocal, right? So negative 3. The reciprocal of negative 1/3 is negative 3. Okay, then you do any shifts. Now that shift is on the outside again, so we are subtracting 4 on the y's. So we're multiplying by negative 3. Multiplication symbols on the wrong side. Alright, and then from there you just fill in the information. Negative 3 times negative 1, 0, negative 3. Negative 1/2, 0, negative 1/2, subtract 4. I'm going to write this as a decimal. So if you do negative 1/2 minus 4, that's negative 4.5. Okay, likewise, negative 4.5 down there, and negative 4. Now, if we were to actually write in the points, normally I would say keep them as fractions, right? But negative 9/2 doesn't really tell you where to put it necessarily on your graph, so I would maybe think about using decimals to kind of help you get that approximate where it should land. So 3, negative 4.5, 0, negative 4, and negative 3, negative 4.5. Alright, now remember, absolute value, that is the V-shaped graph, so we shouldn't have any curve here whatsoever. And more or less, we'd have a really squished, flat-looking absolute value graph for our answer. Alrighty, example C, let's do it one more time. This time we have the description. Alright, so this description is literally just copy-paste, right? I'm literally just going to copy it and paste it. Just make it kind of smaller. Yahoo! Okay, make your life easy. Okay, from here, then it would be, alright, so we have a reflection over the x-axis. Now remember, x-axis reflection is when your A value is negative, or in other words, the stuff on the outside. Alright, so we have an x squared, because we're told we have an x squared, right? And it has a negative on the outside. And then we're horizontally doing stuff to it, so our x on the inside, right? Now if we're horizontally stretching by 3, what that means is that we're multiplying by 3 on the graph. So the reciprocal of 3 would be 1/3. So we have a 1/3 there. And then a shift up by 4 would literally just be adding 4 to your equation. So your equation is g of x equals -1, parentheses, 1/3 x, quantity squared, plus 4. The function notation will be pretty much the exact same thing. You just write f of x instead, or write it in terms of f of x, I should say. So that would be your function notation. So the square is the operation, right? The symbol. So we get rid of that, write f of x in its stead. Stuff against, stuff on the inside, still on the inside, stuff on the outside, still on the outside. Okay? Alright, so let's graph it. So remember, the quadratics have a -1, 0, 1, 1, 0, 1 table. Alright, and then from there we say, great, reflection over the x-axis, that is multiplying by a negative first. Alright, and then from there we are shifting up by 4. So we have -3, 0, 3, -1, 0, -1, and then 3, 4, and 3 when we add those. Two leftmost columns. So we have -3, 3, 0, 0. Oh my gosh, not 0, 0. Hello. And then we have 0, 4. Hello. We shifted up 4. Like 0, 0 doesn't seem right. Yeah, it doesn't. Because it's not. I even put the first point in the wrong place. This is clearly my best problem. Okay, there we go. -3, 3, 0, 4, and 3, 3. Alrighty, and now I say great. Remember, x squared is that U-shaped, right? The parabola. So from there, we are connecting our dots with a nice U-ish shape. Okay, it doesn't have to be exact, but at least get the general stuff down. Alrighty, so write an equation for our last one, actually. Yeah, no, I'll keep it on the same video. It'll be fine. So write an equation for g of x that results in the graph of f of x is x squared, and that is transformed as described. So we're working with an x squared, first off, okay? And then we horizontally stretch by 4. Now remember, you always do the reciprocal when we're looking at the equation. So the reciprocal 4 over 1 is 1/4. So horizontal should be the inside with the x. The operation is a square, so the inside of that would be literally in some parentheses with the x. Okay, to vertically stretch by 2, you do exactly what you see, and 2 goes out front. Alright, and then the shift down, right? Down is that vertical movement. So going and shifting down would be subtracting 10 on the outside, because vertical on the outside of your equation. So this would be it. That would be your equation right there. Alright, last but not least, so for each prompt below, follow the description of the transformations. F of x equals the square root of x, and g of x, and write g of x using the function notation as reading. Using both function notation and as a regular equation. So what this says, and let me make up for my butchered wording, is we're writing two things now. You're writing both function notation and the actual equation. Alright, so let's just write function notation first, because why not? Alright, first off, vertical stretch by 2. Remember, stretch is multiplication, so we are multiplying by 2. Vertical, you do exactly what you see. Okay, then we have a vertical shift down by 1, so you do exactly what it says. It's vertical. Alright, and then you have a horizontal shift to the left by 4, right? Left would be negative. So what's the opposite of negative? Positive. So we have x plus 4 for that function notation. Alright, now if we want to write the equation, it's literally going to be the exact same idea. Oops, got some equals there. Ta-da! Okay. Where we have the 2 on the outside, right? Now remember, we're using a square root here, so 2 times the square root. And then what's on the inside is still on the inside, outside is still on the outside. And that would be it. That would be both the function notation and the equation for this particular problem. Alright, and that is all I got for you. So that is everything with all the transformations combined and how to do them. Thanks for watching.